Hi everyone, this session is about conversion of Epsilon NFA to NFA. In the given example, there are some epsilon moves are there and we need to remove them. There are three states Q0, Q1, Q2 and the only one input symbol that is A. So on each state Q0, Q1, Q2 with the input alphabet A, to what states it is reaching we need to find out. For that, first we need to calculate the epsilon closure of all the states. First we will calculate the epsilon closure of Q0. Epsilon closure of Q0 means the set of states it can reach from Q0 with the epsilon transitions. Without reading any input symbol, it can reach to the state Q0. So self state we need to write first. On Q0, there is no epsilon transition is defined, so that we are going to get only one state, that is Q0. Now we will calculate the epsilon closure of Q1. So without reading any symbol, Q1 is reachable, so that self state we need to write. Q1 on epsilon it can reach to the state Q2, and Q2 on epsilon it can reach to Q0. So we need to write Q0, Q2 also. Now we will calculate the epsilon closure of Q2. Without reading any input symbol, it can reach to self state, so that we need to write Q2 first, and Q2 on epsilon it can reach to Q0, so that the set has Q0, Q2. Now we need to calculate Q0 on A. To calculate this, we need to use the formula delta of Q0 on A is defined as epsilon closure of delta cap of Q0 on epsilon on A we need to calculate. That means epsilon closure of delta cap of Q0 on epsilon is nothing but epsilon closure of Q0. Epsilon closure of Q0 already we have calculated, that is Q0, so that it is replaced with Q0 on A. Now I can rewrite it as epsilon closure of Q0 on A, it is moving to the state Q1, so that epsilon closure of Q1 is Q0, Q1, Q2, so that I can write it as Q0, Q1, Q2 in the NFA. Now we need to calculate delta of Q1 on A. That is epsilon closure of delta cap of Q1 on epsilon on A we need to calculate. We can rewrite it as epsilon closure of delta cap of Q1 on epsilon is nothing but epsilon closure of Q1. It is already calculated, that is Q1, Q2 and Q0 on A. That means epsilon closure of delta of Q1, Q2, Q0 on A means delta of Q1 on A union delta of Q2 on A union delta of Q0 on A. Epsilon closure of Q1 on A it is not defined, so it is phi. Q2 on A it is not defined, so that it is phi union Q0 on A it is moving to the state Q1, so that if you perform union you are going to get Q1. So epsilon closure of Q1, that is already defined as Q0, Q1, Q2. So that delta of Q1 on A we need to write this Q0, Q1, Q2. So in NFA we need to write Q0, Q1, Q2. Similarly, we need to calculate Q2 on A. For that, we need to use the formula delta of Q2 on A is defined as epsilon closure of delta cap of Q2 on epsilon on A we need to calculate. We can rewrite it as epsilon closure of delta cap of Q2 on epsilon is nothing but epsilon closure of Q2. Epsilon closure of Q2 is Q0, Q2 on A we need to calculate. For that epsilon closure of Delta of Q0 Q2 on A means delta of Q0 on A union delta of Q2 on A. So epsilon closure of Q0 on A, it is moving to the state Q1 union Q2 on A, it is not defined, it is phi. So when you perform union operation, you are going to get Q1. So epsilon closure of Q1 is Q0 Q1 Q2. That means delta of Q2 on A, it is moving to the state Q0 Q1 Q2, so that in the NFA we can write it as Q2 on A Q0 Q1 Q2. Now we need to find the final state for the NFA. In the given epsilon NFA, Q1 is the final state, epsilon closure of Q0 don't have Q1, and epsilon closure of Q1 has Q1, so that we need to make Q1 as a final state. Epsilon closure of Q2 don't have Q1, so that we cannot make Q2 as a final state. In this example, Q1 is the only final state. This NFA again can be converted into DFA. Starting with the state Q0 on A, it is moving to the state Q0 Q1 Q2, so that we can introduce new state Q0 Q1 Q2 in the first column. Here we need to fill this cell as Q0 on A union Q1 on A union Q2 on A. So when you perform union, you are going to get only Q0 Q1 Q2 as a set, and there are no more new states, so that we can stop the procedure. So from the NFA, Q0 is the starting state and Q1 is the final state, so that here I can make that Q0 as a starting state and Q1 is final state in the given NFA. So Q1 is present here, so that we can make this state as a final state. So we can redraw this as a transition diagram. Q0 is a one set and Q0, Q1, Q2 as one more set, and Q0, Q1, Q2 is a final state, so that we are making it as a two concentric circles, and Q1 is the starting state. Q0 on A, it is moving to the state Q0 Q1 Q2, and on Q0 Q1 Q2 it is also moving to the self state. By seeing this DFA, we can able to define the language L as minimum string is A and it can have any number of A's, so that we can write it as A power n such that where n is greater than or equal to 1. This is how we can convert epsilon NFA to NFA and NFA to DFA. Please do subscribe and thanks for watching.